Well, good afternoon, good morning, or good evening, depending on where you are in this world. Thank you for joining us on today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. Before we get started on the webinar, which promises to be a really excellent one, as always, I do have a few housekeeping items I do need to go over with you. First of all, today's event is being recorded, so if you miss any or all of the event, you'll be receiving a link post-event to access it on demand. And also, we are taking questions from the audience throughout the entire event. So if at any time you have a question for either of our panelists, feel free to use that control panel, submit your question, and we will be taking a look at the questions, and we'll also take some time near the end of the event to go over any other questions that come in. Okay, with that, we'll go ahead and get started with today's webinar, which is Frictionless Application Development. Radically change how you secure and monitor your OpenShift and Kubernetes environment. Our speakers today are Knox Anderson, who's the Product Marketing Manager at Sysdig, and Eric Carter, who is the Director of Product Marketing at Sysdig. Welcome, gentlemen. Thanks for joining me today.
Thanks, Charlene. Glad to be here.
Great.
Thanks for having us.
Great. Well, Eric, I understand you are taking the reins, so I'm going to go ahead and turn it over to you and let you do your thing.
Excellent. And thanks again. And thanks for the audience for joining us today. And for those of you who are watching on replay later on, what Knox and I want to do today is to talk a little bit about sort of this shift into containers and the goodness of OpenShift and what it means around not just application development, but how you apply things like monitoring and security inside of that environment to really be more effective as you're looking to kind of move more into this digital space, leveraging containers, orchestration, Kubernetes, and so on. I do have a bit of a flight plan we can go over here in our agenda slide. So let's go ahead and look at that. We'll talk about containers and agile development, what the excitement's all about and what the promise of this is all about. And then at the same time, we'll turn to a few of the challenges that we see in and around production deployments. So once you're engaging in developing applications, orchestrations through OpenShift and so on, what are the things that you need to know? And we'll focus that in on monitoring and security side of things. And then talk about how what Red Hat is doing with OpenShift and how what Sysdig is doing with its solutions come to play together to make you more effective. And the good news is we want to get through the slide content as soon as we can so that we can jump right into demo, because we find a lot of value in showing you. So with that, I think we can get started. Knox, are you all ready to go?
Let's do it.
All right, awesome. So we'll start looking at why the hype behind containers. And it has grown more out of, I guess I will say, it's no longer hype, it's now reality. People are excited about it, they're taking advantage of it, and the question is why? And as we look at this frictionless application development, a lot of that comes down to where it starts with developers. Developers love the idea of containers because it's giving them the opportunity to really build code that can be placed into production in a more portable fashion, to move across environments, to be able to have a more iterative development process that helps them deliver code more quickly, make improvements, and so on. And so there's a lot of love for the way that containers enables you to do that. And so therefore, a lot of folks are looking to make this the primary way that we deliver applications. Operations teams tend to love them as well, because obviously, as you're looking at running these applications and services in production, when you can push out code faster and when you can deliver it across multiple environments, which could include private data centers, it could include public cloud data centers, you really can execute on projects a lot faster, but also fix issues when they arise more quickly, because again, that container iteration process becomes very effective. And last but not least, as we like to say, business units love them too. Why? Because again, in the name of we have the greatest, latest and greatest idea, we want to be able to attack a market more quickly and do it cost effectively, so we can innovate and deliver much more quickly as a business using the container construct. And so that's a lot of the excitement that we see around moving to containers is because of these things.
Yeah, and this is also where OpenShift comes in really nicely, making it easier to push out these new containers, operate them at scale, and deliver reliable services quicker.
Now, one of the things that we have identified in and around, I guess, this move to containers is that there is a tendency as each evolution happens out there. So the evolution I'm talking about, once was all about, physical servers, bare metal. We were just trying to deliver applications the best we could in kind of a client server model. Then we decided we needed more efficiency as we moved to virtual machines. And now we're into this era of cloud computing that is becoming more and more focused on containers. So we look at and around those things, the areas of, how do we monitor those environments? How do we secure them? And when things are going on, how do we kind of dig in from a forensics or troubleshooting level? Each of these points in time, if we think about the last, 2 decades, we start to reimagine and have to, in a way, things around storage, networking, monitor, security, because each of these works slightly differently. They bring a different way of delivering machines and applications. And one of the mistakes we want to highlight here is that always there comes a new set of tools. And it can become a bit of a challenge to actually be successful if we're trying to drag something from the past into the new. Now, the good news is that a lot of us in the industry are seeking to help simplify this equation. How do you achieve this next level of effectiveness at delivering applications and services, and at the same time be able to effectively manage that entire stack? Now, one of the things that Red Hat has done is in and around that same, again, evolution into containers. How do you make that, as Knox was saying, more scalable, more, I guess, simplified in terms of how you deliver to market applications based around containers? And OpenShift does a great job of really putting a lot of the pieces together and making it much easier for enterprises to get started. So everything that you see on the screen here, from security, integration management, sort of all of these things are being taken care of by Red Hat, so that you now have a way to get into containers, to get into the orchestration of these often much more scalable environments that, I guess, with the known confidence that it's going to work, that you have support behind it, and that a lot of the pieces have been well thought through.
Yeah, and this is where a lot of the tooling that OpenShift provides, like CloudForms, where you can see your different containers, the packages, the libraries inside them, and then also things like the service catalog, where you can see all the different containers that have been certified and really see a mix and match of the different services and partners that OpenShift will integrate with as well.
Yeah, when it comes down to ecosystem and sort of that certification process, of which we are one, I think they're doing a really great job of making sure, hey, what goes together in this OpenShift realm has been not just certified, but sort of looked at from a, does it work? Is it secure? Is it easy? All those kind of things, right? So a very good partnership that we and others have with Red Hat. Now, as we sort of shift into looking at some of the challenges, and we really do want to today focus around the challenges in monitoring security. So as you're thinking about rolling out more and more applications in this space, what are the things that are arising as potential areas that you need to be looking at to be successful in production? As we think about containers, and we're calling it new technology a lot, certainly we know that containers as a concept have been around for a long time, but the tide in terms of who is going there and how many applications are now being tooled for that has really shifted in the past couple of years. Now, one of the things that is good about a container is that it lets us isolate things like processes and be able to push them out or spin up a container very quickly. But the idea of that isolation also means that in some cases, we break the ability to see what's happening inside that container. And what we'll look at today is, both from a development and an operations perspective, what are some of the best ways to achieve that visibility so that, especially on the front end, when you're starting to roll out something that's new, can I see that everything's working as planned, and is it secure, and all those kind of things. You want to be able to do that even in a container environment where, for some of the legacy tools, it can be a challenge to actually see that, but we'll show you how you can achieve it. The next thing here, new architectures. Look, OpenShift helps make this whole dynamic microservice type of environment a reality, because we're able to schedule our applications to auto scale up and down. We're able to really take control of a much larger cluster of nodes and have that the sort of the luxury of these things being taken care of for us under the hood. But as we auto scale, as we do things like this, how do we achieve monitoring at that scale? How do we secure things as they're spinning up dynamically? Anything to add to that, Knox, in terms of the middle block here?
Yeah, and this is where the integration with the container and the orchestration platform becomes really important. So you need to be able to provide visibility into the services, the different components, and how they're all related to each other.
Yeah, we're going to take a closer look at that in just a second. And then last but not least is really around new processes, right? As we are getting into these kind of environments where we may not exactly know perfectly where everything is running, the good news is, well, the bad news is that it can be 10 times harder to track down what's going on. The good news is, again, there are solutions to that. How do you troubleshoot, audit, and do forensics in these environments? Harder, but not impossible. And actually, together with OpenShift, we actually have tried to simplify that process. And so, again, complications that come along with containers, but there are also solutions to help you in these distributed environments.
All right, so now we're going to talk about some of the requirements for unified container intelligence. And this is really going to come into the 3 different things that you need to do to monitor and secure your environments. So first is, how do you achieve observability? You need to be able to get full stack data about all the connections that are happening between containers, how OpenShift is orchestrating them, and then even down to the process level of what's running inside, any user command, and things like that. From this visibility and observability perspective, you also need to do this with low resource usage while not adding extra dependencies to containers and things like that. Also, because containers are essentially black boxes and they provide that isolation, you need to find ways to auto-discover those applications that are running inside them, and then take that data that's important to your NOC team and your SOC team and combine it so that everyone is doing incident response and recovering, looking at the same data sources, so everyone within your organization is on the same page. Next, taking actions on that data. So containers are really ephemeral, and you need to be able to enforce security policies and block attacks by killing a container or doing something like that based on that data that you see. Within monitoring and security, it's all about, am I going to scale up this service based on a response time? Or if this is an unexpected outbound connection, do I need to kill this container? So taking that observability and then taking actions on top of it. And then the last section on analyzing, both monitoring teams, security teams, SecOps, DevOps are going to want to be able to see, is this issue with the container isolated to a specific host and container, or is this a problem with my logical service as a whole? And this is where the metadata that OpenShift provides becomes really important to kind of stitch together the impact and how different things traverse through your environment. Also, one of the great things about containers, they're ephemeral. You can spin up a new service in seconds, but because of that ephemeral nature, you're going to lose a lot of the data that you normally have for incident response and forensics investigations. So you need to build in some type of tooling where you can see everything that happened pre and post incident. And this is something that we'll touch on a little bit further in the instrumentation and a little bit in the demo, to how you can gain visibility into what happened before an event, during an event, and then afterwards as well.
So let's move into sort of our next section here before we jump into the demo. And we want to talk now about some of the specifics regarding OpenShift and Sysdig. First of all, just really quickly, who is Sysdig? Now, our company was started back in 2013 and started by Laura Stagiani, who, for those of you who are fans of Wireshark, you'll either A, know who he is, or B, know his work, because it's a tool that you've used. And we often ask this question, and most people we talk to say, yep, I've used it, right? So the idea of, I guess, a good background in how do you gain access to data, gather that data, record that data, and be able to present it back for things like analysis and troubleshooting. A good pedigree there here at Sysdig. We are very fortunate to have been engaged with and adopted by many enterprise customers, and that really is our focus at scale with these types of environments. How do you monitor, secure, troubleshoot, and do forensics in those environments? Where we got started actually was with open source Sysdig, what I like to call lowercase s Sysdig. Again, it's an open source tool that lets you troubleshoot containerized environments, orchestrated environments, and that's out there actually. If you haven't never checked it out, we encourage you to do that to see some of the underpinnings of how Sysdig gathers some of the information that it does and how it can help you. At the end of the day, why we're here today with Red Hat and doing a discussion around OpenShift is because, again, we are a certified partner with Red Hat. I think some of the components we'll talk about today, they've all been certified. They're part of the container catalog that's out there for the OpenShift platform and so on. And so we have a really a good partnership with these guys and love working with them. Anything to add there, Knox?
Yeah, on the open source side, if you've used tools like strace, TCP dump, htop, lsoff, what Sysdig really does is combine a lot of the functionality there with full container visibility. And that visibility kind of is the core of our Sysdig Monitor product, all of our open source tooling, and Sysdig Secure as well.
Awesome. So let's get started in the just a quick run through on what Sysdig brings to the table by looking at the architecture of what we do call the Sysdig Container Intelligence Platform. And we call it that because there is a deep set of information that we will gather and collect from basically from everything that you're seeing on the left-hand side. So the application level, container level, host level, network. If you're running inside clouds, the ability to glean information from those clouds and whatever you're running there, as well as the tie-in to orchestration and OpenShift with Kubernetes. And all of that we will take advantage of with two technologies. One is container vision. Now, container vision is our unique way of instrumenting your environment so that we're able to see all the things that are going on in the container hosts and the containers themselves without actually having to be inside the containers. And we'll talk about how that works in just a moment. But this rich set of metrics, information, event information, and so on, we then pair with data that we're getting through another technology that's unique to Sysdig called Service Vision. Service Vision is about tying into the orchestration layer, tying into OpenShift, getting that rich metadata that OpenShift with Kubernetes provides, pairing that with the data we collect from containers, and then being able to take advantage of that inside, again, this intelligence platform. Whether you are a user who deploys everything on your own or in your own data center, so it's on-prem, or if you're completely in the cloud, both are possibilities in terms of how you can deploy what we do at Sysdig to take advantage of it. And the things that we will bring in terms of the capabilities are, one, the ability to extensively monitor these environments with what we call Sysdig Monitor, the ability to secure these environments and do runtime security with Sysdig Secure, see what's happening as you're pushing these applications out and as they're running day in, day out in production. And then last but not least, as Knox was highlighting, this ability to do troubleshooting and forensics even when the ephemeral container is no longer in the picture. It's been shut down, it's gone. Now that becomes a key capability to really understanding what's happening with your applications so that you can, again, be more and more successful with that rollout. If we look at then the OpenShift tooling and what they bring to the table, everything built on top of Red Hat Enterprise Linux, all of the bits and pieces here, and I don't intend to go through this diagram whatsoever, but the point being is there are a lot of parts inside of this machinery that's been very, very simplified for you, but how do we see exactly what's happening throughout that stack? And we're going to give you an idea of how you can achieve that inside of OpenShift or with OpenShift, really, again, without having to do any kind of one-off configurations and tooling for all of these pieces. You're going to be able to see everything right out of the box.
So this is a very simplified diagram of what a container host running on OpenShift would look like. So you've got your underlying host OS kernel that's running on RHEL, and then you can have custom applications running on top of it, or a standard container image like Nginx. From there, the Sysdig agent will install as a container or a process that's running on that node, and that will allow us to do some kernel instrumentation. So that container will load our kernel instrumentation. It's loaded via a non-blocking read loaded via a facility called DKMS. So it doesn't require a kernel restart or anything like that. And that'll give us full visibility into all the system calls that are coming from inside those containers or any process that's running on your host. So from this piece of visibility, we're able to see all user commands that are executed inside the containers, network connections, application metrics, system metrics, things like StatsD and Prometheus metrics as well, without you needing to do any additional instrumentation to your containers, to your applications, or anything that's running on that node. The nice thing here is we'll do all of this auto discovery for you out of the box while leaving your containers fully pure and not adding any extra dependencies. So a lot of other monitoring solutions will do a plugin type model where you might add another process running inside a container, or security tools will go in and do some preloads or inject libraries into the containers. We'll leave your containers completely as is without adding any additional instrumentation. That'll make it a whole lot easier to scale monitoring and security visibility across your environment while also following container security best practices.
I think one of the things that we hear from developers is they love the fact that they know they're going to be able to see everything they really find valuable after the fact without having to worry about popping anything into their code, right? It makes it much more easy. Cool.
So the next thing that we're going to talk about is how Service Vision works. And what we're looking at on the left is probably what a lot of your environments look like. You've got a bunch of different physical hosts, and then there's a bunch of different container services that are being scheduled across those nodes, and they're really treating those underlying host resources as a pool to run different services. So you could have 10 different services on one host, 3 on another, and OpenShift is really deciding what's the best, most resource, the best utilization to run these services. So what Sysdig will do is pull metadata from OpenShift directly, and then give you a much more logical view of what's running on those, running across your environment. So we'll turn this picture on the left into the thing that you see on the right. So you can answer questions like, what's the response time of my Cassandra service that's made up of hundreds of different containers across 15 different nodes? Or you can write security policy to protect logical OpenShift services, deployments, regardless of if they're physically running in multiple regions across multiple nodes, and really give you a service-oriented approach to monitoring and securing your environment.
So I just thought before we get into the demo as the next step here, let's talk about what some of our users have actually achieved, because at the end of the day, it's really about results. And here's one example. So for Pixar, who were really all about trying to enable both developers and operations to be able to see more in and around their OpenShift environment. And just included a quote here that basically helped them really stay on top of the environment, right? They like the fact that it works for their platform as a service, right? So anyone that's running that after everything's been pushed into production, but equally as well for the developers who are, again, trying to keep tabs on how is this thing that I pushed out, how is it working? And how can I make improvements to that? How can I iterate and basically put our business in a better position? Now, Comcast is another example who were really happy about this ability to troubleshoot these issues in and around their Kubernetes services without having to go to this tool and that tool and the other tool and gather all of this information up. Because again, as you'll see in the demo in just a second, a lot of time savings in being able to go to one place, basically a dashboard, click on a few things and be able to kind of find not just the smoking gun, but a good idea of what you need to go fix. And then last but not least, QB, which is, if you think about Nest in the United States, in terms of these really smart thermostats, that's kind of their gig over in Europe. And they are monitoring and securing their primarily Amazon-based cloud with Sysdig. And what they found was previously trying to keep track of all of the tooling that they had for security, for monitoring, was taking two guys pretty much all of their time all year long. And they've reduced that significantly down to like 15 minutes a month of maintenance. And then they get everything that they need from a single set of tooling and a single kind of pane of glass, so to speak. So these are the kind of things that we are trying to help users achieve in OpenShift environments. And how we do that, again, with our entire set of tooling, we're going to focus today on Sysdig Monitor and Sysdig Secure. So what you see in the front row here, we will actually probably take a peek at Sysdig Inspect, which is in the back. Everything you see in the back is our open source tools from Sysdig, and in the front is really our commercial, highly scalable solutions. And so these will be highlighted today in the demo. Speaking of which, Knox, I'm going to hand it over to you if you're ready to go.
Awesome, thanks. And it looks like we got a couple questions in during the presentation, so I'll try to address some of those now as well before we get into the demo environment. So it looks like we got a question about what if the agent gets killed that's running on the host. One of the great things about OpenShift is you can use a facility that's also built into Kubernetes called daemon sets, and that'll make sure that our agent is scheduled on every single node in the cluster. So if the container is killed or if it goes down for some type of reason, OpenShift will automatically restart it because it's something that needs to be running on every single node. For everyone else, as I go through the demo, please chat questions in and then we'll address them as they come up. So one of the things that we're going to do a little differently here is actually show you how the instrumentation works and do a live instrumentation of a container host environment. So what we're looking at now is a blank demo environment I've got running here. It's really sad. There's no data coming in. You can see both Sysdig Monitor and Sysdig Secure have no data coming in this environment. And so what I can do is go over to our settings tab here, go over to the agent installation, and we'll just install the agent as a standard container that's running on the node. And then I'm going to switch back over to Sysdig Monitor so we can see the live data coming in. If I run a quick Docker PS here, you can see, like every single demo, we've got a basic WordPress application that's running here. So 4 different WordPress containers, a load balancer, and then a MySQL backend. What I can do now is install that container that's running on the node. And I'm going to actually remove this -d so we can take a little bit of time to look at the output and see what the agent is doing behind the scenes. So if I run this really quickly and scroll up here, you can see that we're running the module via a facility called DKMS, installing the module on top of that. And then you can see that the agent is going to be doing a bunch of different checks here. So it's going to be checking for different JMX metrics, Java metrics, Prometheus metrics, StatsD metrics, all automatically for you. And then we'll also go and try and pull from specific cloud provider metadata, Kubernetes metadata, OpenShift metadata, Mesos metadata, all automatically within your environment. And be pulling all of that here. If I do a quick refresh on our screen, you can see that that node has now popped up. And if I expand this down, you can see all the same containers that we saw before, as well as the Sysdig agent that's running on that node. From here, we can click on that specific node, see really rich performance metrics about the CPU, the process, the disk at a node level. But then we can go in and look at something like a topology map. And if I switch over to this network traffic, I can see that specific node where we've installed the agent, drill into that node to see all the processes and containers and the network connections between them. So I can see how load is being balanced across my different WordPress services here, how they're all communicating to that MySQL backend. And then even from a security perspective, I can see that SSH process from our local wireline provider to that remote EC2 instance. So getting full visibility into my environment out of the box.
So Knox, we got a question here, which is, how about deploying in an OpenShift environment? What's it like to deploy the agent in that?
Yeah, so in an OpenShift environment, really similar to about the container restarting that I talked about before, we'll deploy via daemon set, and then it's a single YAML file that you'll commit back to OpenShift and will be on every single node in the cluster. Cool. So within here, we can also get really rich visibility into the applications and the performance of the apps as well. So I can go to something like this MySQL container and then switch over to a MySQL view to give us a view of how MySQL is actually performing. And the nice thing here is we've done this without doing any code instrumentation or configuring a plugin for that MySQL container. And that's because we can see the process that's running inside and will automatically trace those system calls. So we can see things like number of requests, number of errors, and then even another layer further where we can see top queries, slowest queries, all automatically because we can decode that TCP connection. So this is something, as soon as you install that agent, you're going to get all of this visibility into your environment. So from a monitoring perspective, you'll get all of this out of the box. And then now let's look at what we'll detect from a security side as well. So I can go back to my instance, run a quick Docker PS, and then a lot of people in the audience are probably familiar with a lot of HIDs, host intrusion detection systems, but you also at a container level need to see what users are doing inside a container and detect things like if a user is spawning a shell in a container as well. So I can go in and start a shell inside this MySQL container, and then go curl redhat.com, execute different commands and things like that. So now let's move over to our different environment with Sysdig Secure and see the type of visibility you can get out of the box with Sysdig from a security perspective as well. So right here, we've automatically seen that shell in the container policy that was fired. So we've detected that user starting a bash shell within inside that container. We can see what host it happened on, the image, and all of those further details. You can also move over to the commands history, and here I'll see every single command that a user has executed on a host, the PID information, the user ID, and all that kind of stuff. So from a high-level overview, hopefully this gives you a picture of everything that we'll discover out of the box, and then how easy it is to get visibility into your environment. So what I'm going to do now is actually switch over to a more robust OpenShift environment and look at some of the details about how you gain visibility into your services and then secure them as well. Before I do that, please send any questions in about the instrumentation or anything else that's coming into our environment. All right, so what we're looking at now is a simple 3-node OpenShift cluster that's running on Amazon. And what I can actually do here is drill down into any physical node, see all the different containers and the network connections between them. And then you can drill down into any host within here, view all those connections between hosts, and then actually get down to the individual process level of what's running inside a container. This is a huge piece of capability on the the monitoring side, because we can actually get down to that process level. So most other tooling will pull the Docker stats API, so you'll be able to see, hey, this container is running at 95% CPU, but not actually what's running inside it and what's actually consuming those resources. All right, so from here, if you're looking at it from a physical perspective, it's going to be a little bit of a nightmare to manage all those different containers. And this is where Service Vision comes into effect. So right now, we've switched over and we're looking at that same cluster, but from a logical namespace perspective. And what I can do here is actually drill down into a specific namespace and service, and then see all the different deployments that are running as part of that project or that namespace. And within a specific deployment, I can drill in, see the different pods, how load is being balanced across that pod, regardless of where they're running, and then actually get down into that pod, see the container, and then the process level of what's happening inside that container. So this is giving you a much cleaner view of those response times of a service as a whole, regardless of where they're physically running.
So it sort of abstracts the host view out of it, right? Because we aren't necessarily concerned about all of the different node physically. We want to know as a pod, as a service or whatnot, how it's running, right?
Yeah, and this is great where you're using OpenShift as your paths, and you have a bunch of different development groups that are deploying their own projects, and you're managing them. So within here, you'll be able to switch easily between the different projects and then the deployments and services that are running within them and how they're performing. There's also some really cool management capabilities around teams and service-based access control that I'll cover later in the demo environment. All right, so now let's move over into our Explore page and go into how you're going to do real-time troubleshooting and visibility into your environment. So what we're looking at now is the last 10 minutes, the different nodes that have been running in my environment, all the different containers that are running on those nodes, and the performance of an individual container. But like we talked about before, you really care about that service view. And so now we can see all those different projects that you have running, and then open up a project to see the specific deployments that are running within that project. From here, you can click on a specific project, and then we'll actually give you really rich information about the health of that service as a whole. So we're seeing all the different request counts, the response time of that deployment, how many containers are being distributed across that environment, the container count, really rich information about things like pod restarts, so you can look for crash loopbacks in your environment, and just giving you a nice overall view of that health of that service. From within here, you can also get in further to that application level. So I can go in and look at something like JVM metrics, look at the JVM heap used for that deployment as a whole, see how memory is being consumed, and then actually go in and look at how this is the heap information at a pod level. So I can switch over and now segment this data to see how are the individual pods that roll up into that service affecting that service as a whole. And this gives you a really nice way to explore dynamically through your environment, filter and troubleshoot and segment all your data based on any piece of logical metadata that OpenShift will provide. Within here, we'll also be able to give you the ability to create alerts. And the nice thing, if you're creating an alert from the Explore table, is you're going to automatically pull in all of that metadata out of the box. So this alert will be scoped to a specific namespace, to a specific deployment, and any new container that's added to that namespace and to that deployment will automatically have this alert applied to it. If you want to alert for the service as a whole, then you can remove this segmentation here and get full visibility into that service and really reduce alert fatigue by not alerting on the individual components of a service. From here, you can send the alerts out to any one of your existing notification channels like Slack, PagerDuty, VictorOps, SNS topics. A lot of customers are also sending them to CloudForms and tools like that. via webhooks. And then you can also activate the Sysdig capture, which is going to give you all of the different system calls that are happening in your environment at that point in time when the alert occurred. And we'll actually go a little bit further into Sysdig captures when we move over to our secure environment. On the alerting side, we'll also give you the ability to alert on downtime events, events that are coming specifically from OpenShift or from the Docker engine, like pull requests failing, if a crash loopback event is occurring, replica set scaling, and all those kind of things will automatically ingest. And then also give you the ability to set up anomaly detection and group outlier alerts on things like your load balancers or the different services that you have deployed. And then before we want to jump over into Sysdig Secure, let's talk a little bit about how you can give your different operations teams the ability to segment their data, secure their data with this piece of functionality that we have called Teams. So Teams, I like to call, everyone's heard of RBAC. I like to refer to Teams as SBAC, so service-based access control. And so I can go over into Teams here, see all the different teams in my environment. And what a team allows you to do is segment the data that users have access to based on any piece of host or container metadata. So if you want to go in and pull metadata directly from OpenShift and say, okay, this group of 10 developers only has access to data from this project, they can't see any of the underlying host information, you can easily create that within here. And then that team will have their own set of dashboards, their own set of alerts, customized to that individual team. This is nice for two reasons. One, it's definitely a more secure way to expose data in your environment. You're only getting information for that specific service. And then also, if you're a backend developer or if you're managing a PaaS, if you have a bunch of different teams using your service, if one of them is having an issue, you don't want to have to filter through all the data in your environment. You want to just switch over to that team and see exactly what they're looking at, their dashboards in a fully sandboxed environment. And that's something with orchestrated environments, all of our different customers are deploying and making it easier for their different developer groups to adopt tools like OpenShift and containers. So hopefully this gave you a nice overview about some of the capabilities that we've got within Sysdig Monitor. And now let's go look at what we can provide from a security perspective with that same agent as well. So what we're looking at now is a feed of all the different security events that have happened in my environment. But before we dive into any events, let's look at how you configure policy to detect events that have happened in your environment. So out of the box, we have a range of different policies that come from a couple different sources. A lot of our default policies are from different CIS controls and best practices. Then we also have default rules and policies that have come from the Falco open source community, which is our Sysdig Falco, our open source tool. And you have companies like Yahoo, and then organizations like Cloud.gov that are using that open source tool to protect their environments. And they're contributing back to the project, and all those rules come into Sysdig Secure. And then there's also a bunch of policies that we've developed from our experience managing and monitoring millions of containers with Sysdig Monitor across our customer environments. The thing that's really unique to Sysdig Secure is our ability to configure policy based on any piece of that host or container metadata. So a lot of people think about security at the image level, but with the rise of open source tooling and how easy it is to pull down images from things like the OpenShift catalog, you really want to think about security at a service level. So if you're using an image like Redis, for example, you could have that image in a data processing service. You could have that image in a caching service for your billing application. You can be using that same image in a bunch of different areas, and you want to write different security policy based on that logical service and the compliance needs for that service. And what you can see here are the different policies that we have and where they've been scoped. So if this policy is protecting a specific image, if it's protecting a logical Redis service from there. So within a policy, we give you a bunch of different controls around writing basic rules to detect process violations, then network connections, so inbound or outbound connections, unexpected read-write operations, and things like that in your environment. Or you can use the Falco rules, which are used for more advanced detection mechanisms. So I want to detect if a curl command was executed, and I only want to be notified if it's coming from an attached terminal. So if a user executed that curl command, and that's where you would apply those Falco rules. Off of any policy, we can take action. So you can do something like stopping a container to block that attack from spreading, pausing a container to quarantine it, or you can trigger that Sysdig capture. And building on that Wireshark knowledge that we have here, a lot of you guys have probably heard the phrase PCAPs or it didn't happen. What we do here at Sysdig is we store this capture file as something called an SCAP, which is going to have all those system calls that happened for the 15 seconds leading up to the event, what's happening during the event, and then a customizable time frame after. So on a policy by policy basis, you can choose how much data you want to collect pre and post that incident for your different compliance and forensics needs. Off of any event, you can also send them to your downstream tooling, like your SIM. So if you're using something like Elk or Splunk, you can easily send any different security event to your environment there. So now let's move over into our different policy events to look at what's actually occurred in our environment now that we've seen how you can create policy. So like Sysdig Monitor, you can also group all your data based on hosts and containers to see specific hosts where events have occurred, the different containers that are running on that host, a specific event that's happened on a container, or you can view that data at the service level as well. So now if I switch over to the service-oriented view, you can also look at it from a topology perspective to see which physical and logical areas of your infrastructure have had security events. So what you can do within here is drill into a specific project, see your different deployments in that project. And then if I just double click on a project here, we'll be able to drill down into a specific event that has occurred. So what we're going to do now is go through a little bit of a typical incident response workflow that a customer would go through, and then talk about how you can do forensics investigation as well.
I almost feel like I should hit a stopwatch right now because it's going to happen very quickly, right?
Yep.
Just to show the effectiveness of the tooling.
So first things first, you can click on that event to get a bunch of different metadata about where this event occurred, what different services that this could affect, and things like that. So off the bat, we can see where this happened in both my logical infrastructure, so the different deployments, the pods, as well as my physical host and container. What's really nice here is normally if you want to do this type of correlation, you're going to have to do a ton of manual log correlation. So you'd have to take the image, then see all the different deployments that image is running into, cross-correlate that with the container ID, do reverse lookups, stuff that's going to take 15 or 20 minutes to actually correlate this across your entire environment. And all this metadata you're going to get out of the box when you drill into the event. From here, we can see further details about a capture was taken, that the user spawned a shell, and then we can also see commands that were executed around that event as well. So the first jumping off point I'll want to do here is look at the commands that the user executed once they started that shell in the container. So from within here, I can click on View Commands, see, okay, the user started that shell process, they curled down a URL, and then untarred it. From within here, I can actually click on any row to get further information and see the full URL. So it looks like they actually curled down a rootkit. So this is something that I'm going to definitely want to do further forensic analysis on. And then the further information around the PID, user ID, and those kind of things. So since this is something I definitely want to escalate, I can click over onto captures to view that capture around that shell in a container as well. By clicking on this button here, we're going to open up Sysdig Inspect. And Sysdig Inspect is our GUI for really rich forensics, and troubleshooting analysis. So what this is doing is taking that raw dump of all those system calls and giving you visibility into everything that's happening. So I can see that point in time when that specific event occurred, and then start to do really rich correlation across my environment. So I can see the modified files, the access files, file bytes in and out. I can look at network bytes in, and then those executed commands that we saw as well to do correlation across file, network, user commands, and then when that event occurred in my environment. From within here, you can also use these sliders to filter the data and only show what's actually relevant to that point in time when the incident occurred. So right now I'm getting sub-second granularity of everything that was happening in the environment. I can click on those executed commands here, get that same view that we saw before, but then actually go in another step further and see what exactly happened when that user untarred that rootkit that they installed within the container. So if I double click on this, we'll drill into that individual command. And then since we see all this file activity here, let's switch over to the files view. By switching over to files, now I'm looking at every single new file that was written from that tar process, and then actually get full visibility into everything that was now introduced to my system. We can actually go another step further since we sit at that system call level and look at all the I/O activity. And I can actually use this I/O streams functionality here to drill down in and see the individual writes that occurred to a directory. So we can see now the contents that were written to that README file within the container from unzipping that rootkit. So to take a step back, what we actually did here was go in from a specific event to the commands, to the files that were written inside a container, to the individual contents in a file without ever having to leave the browser. And this visibility is something that normally you're going to have to do tons of different correlation, pull together network analyzers, file analyzers, look at logs, all those kind of things. And because we have this deep system call visibility, we're able to give you all of this in a really rich unified workflow. The other nice thing, just from an incident response and kind of CSERT team perspective, is you can copy this URL, send it over to anyone on your team, and they're going to get dumped down into the exact same thing that you were looking at. So no context is lost as you're going in and doing that forensics or incident response workflow.
It's awesome. 3 minutes or less, you figured out what's going on and you're shared it with your team, right? It's pretty cool.
Yeah, and from a audit side, all of these are stored as SCAP files, so you can choose how long you want to retain them, where you store them, and all that kind of stuff on whatever your organization needs. One last thing, and then we'll open it up for Q&A. We've touched on the commands history a little bit so far, but I just wanted to show you a little bit more about how it can be used to audit commands across your entire environment. So here we can see all of our different hosts. I can move over to the last day, see every single command that was executed on a specific host, drill down into a host, see an individual container, the commands that were executed there, and then we can actually do something like look at anytime a user executed a bash command, and then filter on a specific user within here as well. So you can see anytime a user is executing sudo, bash, really anything that you want from a auditing and forensics perspective with the commands. So hopefully that gives you a kind of quick overview of everything that we've done. I know we've covered a lot between monitor and secure, but thanks for sticking with us, and we'll open it up to questions now.
All right, great. We've gotten a couple questions in during the demo, so I want to go ahead and ask those. But guys, we do have about 6 minutes to the top of the hour, so there is time still if you have a question regarding the demo, regarding the technology, regarding whatever. Go ahead and use that control panel, get your question in. If for some reason we don't get to all the questions by the end of the presentation, just know that we'll be sending all of the questions over to the fine folks at Sysdig. So Knox or Eric or one of their team members, I'm sure, will be more than happy to follow up with you. Okay, here are the questions that came in during the demo. Chet asks, how does the traffic inspection address TLS connections?
So that's one where we're going to need to punt that because it's a little bit of a longer discussion here.
Okay.
One of the things that I saw in here from Bivin was, what is the storage mechanism behind Sysdig Analytics? Great question there. So we have a couple different backend services that we use. So all of our metric store is sent to a Cassandra backend, and then the different security events are sent to an Elasticsearch service. That service also pulls in all the different events from Docker and Kubernetes as well. One of the other interesting facts about the backend and the architecture and things like that is you can deploy our entire service that you've seen here via OpenShift as well. So you can use OpenShift to manage our collectors, the Cassandra service, the Elasticsearch service, our workers, and all that kind of thing. So if you want to use us as an on-premises software, you can use OpenShift to actually manage that console and that service and everything.
And that's good because you hit on one of the other questions, was what's the difference between the SaaS and the on-prem? You described one is where you're going to run all those components and control all of that yourself. The other is where actually you're just tying into what Sysdig runs in a cloud, and the containers that are there collecting those metrics and everything from your hosts will be pumped up into the cloud, and we're the guys taking care of all that, or you can do it all yourself.
Yeah, and the nice thing here is whether you choose SaaS or on-premise, the user experience with the product is the exact same. So all the functionality that's in SaaS and on-prem, same offering. You probably are just going to have to wait 2 weeks longer between on-prem and SaaS on that release cycle.
All right, great. We have another question here. Does the solution support container runtimes other than Docker?
And the answer there is yes. I mean, we often focus a lot on just the Docker stuff that we have set up in our demo environment. But whether you're running Rocket, LXC containers, again Docker Engine, and just about anything that because of the way we instrument, we're going to be able to pick up what it is, because we identify the processes that are very unique to some of those container runtime environments, and often in the UI we're going to actually display a little icon that shows you the difference between which is the container engine that's running.
Yeah, and that's because of our kernel instrumentation there. We can actually see the individual system calls coming from C groups and namespaces and things like that. So we're looking at everything from a C group level. So we're really container agnostic. So if you're using LXC, Rocket, Cryo, Docker containers, we'll be able to get that visibility.
Awesome. Okay, I think we have time for one more quick question. How does Sysdig Monitor integrate with Prometheus?
Yeah, so great question there. Prometheus is an awesome format to send metrics, and we'll actually pull those metrics directly from your environment. So we'll pull those metrics without you needing to do anything, store them for you, fully tagged with all of that OpenShift metadata as well. So if you have Prometheus exporters or things like that, we just recognize the protocol, and then we'll pull those metrics automatically. So the same thing that we'll do with StatsD or JMX, where we'll pull those from inside the containers from the host, we'll do with Prometheus as well.
Okay, great. I believe that that's pretty much all the time that we have for the questions. If we didn't get to your question, as I said before, please know that Knox and Eric will be getting a copy of all the questions. So I'm sure they'll be more than happy to address them offline, or a member of their team. Also, keep in mind that today's event has been recorded. So if you miss all of the event, you will be receiving a URL hyperlink in the follow-up email that will take you to the event on demand. So feel free to listen to it whenever you want, share with your friends, whatever you want to do. The event will also be available on demand on the devops.com website. And while you're there, just take a moment, look at some of the other webinars that we have on the site. Hopefully there'll be one or two that pique your interest. Knox Anderson, Eric Carter, thank you both for joining me today. That was a really, really interesting webinar and a great presentation demonstration. Thanks to you both. I appreciate it.
Thank you.
Thank you.
Thanks to the audience.
Yes, thank you to the audience for joining us today. I'm Charlene O'Hanlon, moderator for the event, and I'm signing off. Have a great day, everybody.